So with the first operation completed, I'll bring my tool in to touch the rear register of my mandrel. I've set the 0. I haven't touched the diameter at all, the 0 on the DRO for the diameter, so I know I'm still set to where I want to be. Basically, I want to come back, the finished thickness of my part is going to be 34 millimeters. So what I'll do is come back until I reach, I'm just creeping up on it, 34 millimeters on my DRO, and I'm going to reset that to 0, and 0 will be the position where I face the other side of the part to its finished size of 34, and then obviously I can go from that 0 to 10 to do exactly the same shoulder on the other side. So let's do one of those. So I've turned the second diameter down, 29mm, to exactly the same readings on my DRO. So what I've done, I came back 34mm from this face to this point here, 34, set it to 0, and I've machined it to that 0 figure. So I know the overall length is 34. And again, down to the 0 mark on my DRO for my 29 diameter. I am now facing this back face to give my 10mm step. Ideally, this center theoretically should come out to 14mm, or, you know, plus or minus 0.1 at the end. So anyway, I'm at 10 on my DRO. Against the stop, I've just adjusted it, so let's just do the final cut. Cross space. This is a 0.1mm scratch, that's all it is, just to get a nice finish. Down to the root, 0 on my DRO, and ease it back out. So theoretically, the thickness of that major diameter should be 14mm. Let's have a look. Okay, I have had a sneak preview, but I'm quite happy with it. Hang on, one hand on the calipers. Let's have a look. 13.9, absolutely fine. What I'll do is adjust my original 0 from the 34 for the next ones from this point here, and I shall adjust it by 0.05 to get me closer to my tolerance. Let me just have a look at that step height. Yeah, there it is, 10.08. There we are. I've scratched a little bit too much off that back face. So theoretically, what I can do is increase that by 0.05. That'll stay at 10.08. So if I increase this position for the overall length, I should come into somewhere near. But having said that, it's intolerance anyway. So we're getting on to the final operations. My drawing calls for a 45-degree chamfer on the corner here by about 0.5 mm, and on the top edge here by 1 mm. So I'll just pop those on. Here we go. I've just set a tool up here. It's not fussy, this. Just break the edge of that one. I've made hundreds of these things and I can pretty much visualize it now. And there we are. That's 2 chamfers done. Final operation on these is a chamfer on that bore. Let me have a quick look at my drawing. I believe it is 30 degrees by about 1.5 to 2 millimeters. So I'll set my boring bar up, set my compound slide up, scratch through that side, turn it around, scratch the other side, and that's the job done. So to get a consistent chamfer on the inside, what I've done, I did my first one, and when it was in its finished size, I've set my carriage stop. I'm not moving the cross slide at all. I'm doing the cut with a compound slide, and what I'm doing is progressively moving the carriage forward to increase the depth of cut. When I run the compound slide through and I'm against the stop, I've achieved my depth. So let's just do the finishing cut through there and against the stop. Back out. Now I can just wind the carriage out of the way I know I'll come back against that stop for my finishing cut and just use the compound slide to do the actual cut itself. And I end up with a consistent chamfer, exactly the same on both sides. So some people may ask, why am I machining this on an expanding mandrel? I've made lots and lots and lots of these components. I found this is the quickest, simplest way to do it for me. The setup time is, 2 seconds in and out. Consistency of setup. Once I've done the bore, they can take them on and off, back in the same place every time. One of the other advantages is if I were turning the outside first and then boring it, what have you, I would have to be holding it in a chuck of some description. I haven't got collets that will hold it. I mean, that would be another way of doing it. To machine the one side first on all of them. Maybe bore them out, maybe use a collet, something like that. But I haven't got them. So this expanding mandrel covers lots of areas for me. And the other advantage is obviously everything stays concentric to the bore. And the other bit of good news is I haven't got to grip it in a chuck, in and out with bits of soft jaws and all that sort of thing, which might damage the outside of the part, or the inside for that matter. So yeah, it's one of those circumstances where an expanding mandrel is the ideal tool. And it probably took me, I did make it some time ago. As I said, I've made quite a few of these. And it's the ideal thing for this. I can get to the inside to do the chamfers afterwards, all in one setting. Everything stays concentric, even the chamfers. So yeah, expanding mandrel, ideal. And to make the mandrel itself takes, if it took me half an hour to make it, that'd be it really quick, simple turning job. Bit of work with a hacksaw, yes, okay, but that, it doesn't take long. But yeah, that's using an expanding mandrel. The only thing I find I do have to do from time to time is to skim the diameter, hold the acting part, the 23mm, gently in the 3-jaw, make sure it's running true, and then just take a slight skim off the back from time to time, because obviously it's in and out the chuck, and that does get marked up. So basically I move it around every time into a different place with no marks. Once I've used it 3 or 4 times in and out the chuck, I then have to just give it a light skim, but it's a thou or two. But yeah, that's using an expanding mandrel in the lathe.